Hi guys, today we are going to talk about resource acquisition is initialization C++ programming technique, or just RAII. So it's all about resource management in C++, such as dynamic memory allocation, open files, open sockets, lock mutexes, etc. So this technique guarantees that all acquired resources are released when the lifetime of the controlling object ends. In other words, it encapsulates each resource into a separate class where firstly the constructor acquires the resource or it throws an exception if that cannot be done, and the destructor that releases the resource, acquired resource, and never throws exceptions. Okay, let's start with the first example. We have constructor and destructor at the output string accordingly to the function. Cool. We create row pointer using new operator and delete this object using delete operator, and of course we have no leaks. So if we will start our program, we will see that we have constructor call and destructor call. Cool. But what if we, for example, create a new function called process widget and we pass widget pointer, const pointer. We do something with this widget and then we just want to check some things and we throw exception. We will catch it. Cool. And if we catch it, return 1. So that indicates that we have an error here. And it's the main function. We'll just call this function. Our widget is the argument. And if it return 1, so we return 1 too. And there is a problem because let's start our program and see. As you see, we just have constructor call output. So because of we return from this point. So there is a problem, and what we can do is this. So starting from C++11, the standard library includes smart pointers, which are used to help us ensure that programs are free of memory and resource leaks and are exception safe. So there are 3 types of smart pointers in standard library. It's unique pointer, shared pointer, and weak pointer. The difference between these pointers and deeper information we will discuss in the future videos, but for now we'll just use unique pointer and let's see what we can do with this thing. So let's try to use smart pointer. Cool. Unique ptr, where is it? Okay, cool. With widget type and just create widget using the same new operator but using unique ptr as a wrapper for our object. Okay, smart. Yeah, cool. And just comment these lines and let's see what happens there. If we run the program, of course we will see that we have constructor and destructor called because after program is return 1 from the main function and it stopped, it calls automatically call destructor of this object. So let's see another example. let's just remove this one and this one. Let's grab this in the block, call, and just see what happens here. After look, call. And if we run the program, we will see that the structure calls immediately after block after ending of block. There is it. So let's see another example with mutexes. So we have mutex. Let's just create another function and call it something bad mutex usage. Cool. If we just log this mutex, something we do there, and we unlock. Cool. It's fine, we have no errors here. Just call this function here and return 0. Cool. Cool. When we run the program, without errors. Cool. But what we can do there in this code, what if we return 1 here and unlock function will not call. So if you run the program, we receive an error, of course, and that's problem. So what we can do in this situation with the error? So let's just remove this function and this one, and let's create our RAII wrapper. So lock RAII. Okay, let's create private data member. It will be std mutex pointer mutex. Cool. And let's create public public constructor. It will be explicit. I'll talk about it in a second. So our mutex as our parameter. Mutex, cool. Let's just assign it with our mutex. And in our constructor call, we will lock our mutex. So mutex lock, cool. And in our destructor, when the object will be destroyed, we will call our mutex unlock. Unlock. So that's cool. So explicit is needed to avoid implicit conversation to our object type. Cool. And let's just add our debug string. I think it will be useful. Let's just create lock and just unlock. Cool. Let's try to use this function. Can we use avoid? The return type and good mutex usage. Cool. Let's just create object of type locker AI, locker and send our mutexes argument. Let's just call this function and let's run our program. So as you see, we have our mutex log and our mutex unlock on our object destroyed, locker destroyed, when our function called. Cool. Okay, and I want to mention an important thing. Okay, and I want to mention one important thing. So, starting from C++11, we have two mutex wrappers, logguard and unique log. Starting from C++14, we have shared log wrapper, and starting from C++17, we have scope log wrapper. Differences between these wrappers you can find on the official CPP reference, official doc, and maybe in my future videos. Cool. Let's just see how to use, for example, logguard wrapper in our code. So let's create another function. We'll name it cpp11 mutex usage and just use our standard library mutex wrapper named logguard. Cool. And point our mutex type as logguard type. And let's create got it mutex cool and send our m as argument. Okay, and if we will call this function instead of this one and run our program, we will see that there are no errors and everything is fine. And the last one thing I would like to mention is that we have to make our resource wrappers be copyable object. So we should prohibit to copy our wrapper objects. For this thing, we should create, we should make our copy constructor as a delete constructor. So just by reference, make it delete and copy assignment operator should be to delete reference delete. So I advise you to use this thing for resource wrappers. Advise you to make a separate class if we have more than one resource resource wrapper classes. So just make separate class to prohibit copyable copy object. So let's create a constructor default and constructor cool and make uncopyable. So for this thing we just prohibit our copy constructor and prohibit our copy assignment operator. Cool. Delete. Cool. And the last one thing we should do is that we should inherit and make private inheritance from this class and copyable, and we can delete this function. They are not needed to. So that's it. So at the end of the video, I would like to repeat key things. It's first of all use RAII objects to acquire resources, smart pointers for dynamically allocated memory, mutex wrappers for mutex lock and log, and of course it's prohibit copying of the resource wrappers objects. That's all for today. Thank you for watching. Leave a comment below about what do you want to see in the future videos. See you guys.